Okay, guys, so let's talk about naming organic compounds. The first thing we need to talk about is we need to talk about our root name, which is based upon the number of carbons in our carbon chain. And so let's get through that real quick. You'll need to memorize these root words, if you will. And so one carbon chain is the root word for one is meth, and for two is eth, and three is prop, and four is bute. 5 is pent, 6 is hex, and if we go up to 7, that would be hept, and 8 would be oct, and 9 would be non, and 10 would be dec. So there are our roots. You need to know these. You need to memorize them, so commit them to memory today, if you will, because they're going to be very important. You're going to be using them a lot. Okay, and so let's go to our rules. You need to write these down. So these are the basic rules. This is just real general, so you'll kind of see how they work as we work them. So the longest chain determines the root name, number of the carbons from the end closest to a substitute, and we'll talk about substitutes in a little bit. And then substitutes are listed alphabetically. And now let's talk about just a few extra little rules, if you will, that will help you do organic chemistry. And so here they are. Carbon likes 4 bonds. Nitrogen likes 3 bonds. Oxygen likes 2 bonds. And I'll go over here. Hydrogen likes 1 bond. And halogens will also want to have a 1 bond. The basics of organic chemistry is right here. Carbons bonding to hydrogens. That is what organic chemistry is all about. Carbon and hydrogens bonded together. And so let's look at the simplest organic structure. It would be this: a carbon bonded to 4 hydrogens. That would be our simplest organic structure, CH4. Now, if we name this via our covalent naming rules, then you would probably name this carbon tetrahydride. And if all we did was is molecular naming rules, and we never went into organic chemistry, this would be acceptable as far as I'm concerned. But we are going to do organic chemistry, so we just need to name this organically. And so we would use our roots up here. In this case, we have 1 carbon in our root, and so our root is methane, 1 carbon in our chain. So our root is meth, and in this case, this is actually methane, is what this is called. It is methane. And so let's just do some practice. Let's get into the basic organic structures. And so we're going to talk about alkanes first. And in an alkane, which is just a class of organic compounds, all of the carbon-to-carbon bonds are single bonds. Carbon-to-carbon single bonds is what we're going to have here. And so let's look at a simple alkane. Methane is a simple alkane. There's only 1 carbon, so there can't be carbon-to-carbon bonds, but it falls in the category. This would be our first one with more than 1 carbon. And so our carbon-carbon bond is single bonded here. Now, we have 4 bonds for each carbon. So you can see I have my 4 bonds for my carbons. What are they going to be attached to? So remember, organic chemistry is about carbons bonding to hydrogens. So we are always going to make the assumption that the bonds are filled out with hydrogens unless you are specifically told otherwise. We will always have hydrogens at the end of these bonds. And so this would be our simple structure for our 2 carbon alkane. And so how do we name this? Well, here's how we name it. It is part of the alkane family because the carbon-to-carbons are single bonded here. And so we're going to use that part of the name right there, the ane part, the ane part. If we go back to our roots, we have 2 carbons, and so it is eth. And since it is an alkane, it is going to be ethane. And so that is going to be the name of this. It is ethane, is what it's called. And so let's go to another one. Let's say that in this case we had 4 carbons in our carbon chain. And again, carbons like to have 4 bonds. So we need to finish out giving each carbon 4 bonds. And since we're talking about real simple structures at this point, all of these bonds are going to be filled out with hydrogens at the end of each one. So hydrogens all the way around. And now we're going to name this. How long is our carbon chain? How many carbons are in our chain? We have 1, 2, 3, 4. If you go back to our roots, 4 is a root of bute. And so in this case, this will be butane because it's an alkane. All the carbon to carbons are single bonded. So we're going to use the alkane, the ane ending. It's butane. So how many carbons are in this chain? There are 6 carbons. Now what I'm going to start doing is I'm going to stop drawing all the H's because it gets to be tedious. The understanding is if I draw this, you understand that at the end of each one of these bonds is a hydrogen atom. That's what you understand to be. I'm not going to draw them all. We got 6 carbons in our chain. We go back to our roots. If you look it up, it's hex. Since they're all single bonded carbons, every one of these carbon bonds is a single bond. Single, 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 single. That means it belongs to the alkane family, so it is hexane. That is the name of that organic structure. Let's talk a little bit about formulas, different kinds of formulas. And so we've done a few. Let's kind of get into the differences. So once again, I'm going to leave the H's off. You write them down or you understand that they are there. And so this little illustration, I'll go ahead and write them in for this illustration since we're trying to get to the actual technical terminology. And so this is what is called a structural formula. A structural formula, sometimes called a graphic formula because it graphically depicts the arrangement of the atoms. We could condense this. This formula could be condensed into this CH3, CH2, CH3. This would be a condensed formula because we have taken the little bond sticks out, if you will. And you can see here what we have is we have right here, we have a CH3. And that corresponds to that CH3 right there. And then we have, right in the middle, we have a CH2. And that corresponds to this CH2 here. And then we also have a another CH3. And that's this one over here. And so we're just kind of condensing it down. It still tells you about structure. It tells you that we have 3 carbons interchanged. We have 3 hydrogens on this one, 2 hydrogens on that carbon, 3 hydrogens on that carbon. So it still does show you some of the structural nature of the compound. But this is condensed. We could take that and we could also write this as C3H8. And this would simply be the molecular formula. So 3 different formulas of this, in this case would be propane because it's got 3 carbons. We have the structural formula, the condensed formula, and the molecular formula. And so let's do one more of those as practice. And so I want you to write all 3 formulas, the structural, condensed, and molecular formula of pentane. And so go ahead and pause the video and write those formulas out and then restart the video. And so if you're looking at pentane, pent means 5 if you're looking at the roots, and it's an ane, which means all 5 of those carbons are singly bonded. And so if you're going to draw the structural formula, you will draw out 5 carbons in a chain, singly bonded to each other. Now you have to give each carbon 4 total bonds, so just complete out your bonds to give each carbon 4. And at the end of each one of those bonds would be a hydrogen atom. and that would be the structural formula. Now the condensed formula would be CH3, CH2, 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 CH3, and the molecular formula would be C5H12. That would be your molecular formula. Now I do want to do one more thing here, because you can actually condense this condensed formula a little bit further. So let me show you what it could be written as. It could be written as CH3, CH2, 3, CH3. What we're doing here is we're taking this CH2, there's 3 CH2s right here. There's 3 CH2s in the middle of our chain. And so we're saying, hey, I've got CH2 back to back to back 3 times. And that's what I've got. You could see it like that, and you could write it like that. Either of these formats is good to go. Check mark. Okay? So there's our organic basics.